why not? So the other thing is I do have, I'm going to be posting a couple of video clips today on activities or things that you're supposed to be learning in the first chapter that may be a little bit tricky. Turn that off. Okay. It's always a little delayed. All right, good morning. So Alexis, you can turn on your mic if you want. This is question and answer time, but we're going to talk a little bit about the class. This is my office hour. So you guys are actually, you're my first students to come to office hours. And it's a chance for you to ask questions, or I can explain things, I can explain concepts. And, this is not a lecture time, but I mean, I can certainly use it if you want to use it for that time. We could do that as well. So the beginning, you guys don't know me yet. So this is kind of like a chance for you to learn a little bit about me. Actually, in my office hours, I don't have to be quite as formal. I don't have to be formal at all, actually, because we're an online course. I mean, I can be formal, I suppose, but it's meant to be, this is actually a really fun course. And the topic is interesting. And I guarantee you're going to learn something amazing. I mean, you'll probably learn something amazing quite often. But the goal is that you, as you learn, you probably will start to ask more questions. And at the end of the course, I will not have all your questions answered, because the more you learn, the more questions you ask. But hopefully you'll have a pretty solid foundation about astronomy and about this part of science. Have you taken another science class before?
I have.
You have, okay. So you know about, for example, the scientific method. That's kind of one of the ideas that. So in my lecture, I would have talked a little bit more about science and how we develop science, but you're here, so I'll tell you what I think. It's kind of like, do you know Isaac Newton? Actually, that name pretty familiar? Or
yeah.
Okay, good. So we're going to talk about him in chapter 3. He's a pretty big guy in physics and astronomy, because he figured out how things move and why they move. But actually, it's funny, because everything that we understand about what he did, we've now kind of have layers on top of it. But anyways, he did most of his work when he was in his 20s, believe it or not. Are you 20?
Yeah.
You are, okay, all right. Yeah. But anyway, so this could be the beginning of your big work. Who knows? But and then after he did his big work in his 20s, he kind of went off on a tangent and actually became a little bit strange. I'm not going to tell you much about that, but he studied something called alchemy. Have you heard of alchemy before? Alchemy is this idea that you can change kind of common metal like lead into precious metal like gold, and that there would be a mechanism for doing that. And he was obsessed with that for the last part of his life. And he kind of went a little bit crazy in his pursuit of that. So we don't talk about that much. We talk about his work that he did in his 20s. But anyways, it's kind of a funny thing. But anyways, he was finally recognized for this great work that he did. And he was given a position. He was appointed to the Royal Academy of Science. And so that was a big deal back then. That was kind of like the best, the pinnacle. You were kind of like a Nobel Prize or something. And so he stood there actually and addressed the crowd. He's like, "Thank you, my peers, blah, blah, blah." And he said, there's this quote that I really like. He says, "If I have seen far, it is because I stood upon the shoulders of giants." And I think that kind of is the scientific method, that we don't do anything by ourselves, that science is all about building on top of what has come before. And so Newton was, just talking about, his great results that he had were really important, but he couldn't have done any of that without the work that came before that and the people that came before him. So I really think that's an important idea, that no matter who the scientist is, the work that they've done is building on top of what came before. Science is just a little step at a time. It's not usually big jumps, right? It's usually little tiny jumps, but one after the other. And so over time, we gradually, build ourselves up and we learn more about the universe. So it's kind of a neat thing, neat process.
Yeah, definitely a neat process. I'm excited to learn about astronomy.
Good, good. So do you look at the sky at night sometimes?
We have a
You do?
deck, so we can actually see.
And fantastic, cool.
Yeah.
Do you usually see the sun in the daytime from your
Yeah.
deck? Okay,
Yeah. The sun hits
cool.
pretty hard on our house,
It
actually,
does?
so it gets hot
Okay.
very easily.
So actually, let me ask you a question. Do you know what direction the sun is when you see it during the day? What direction
No,
would it be? Towards the north or towards the south? Do you have any idea?
I would say towards the south.
That's correct. Very good. That's awesome. Good job. And
Yeah.
that's actually part of what I'm going to ask you to do is recognize these patterns that maybe you've never seen before or never really like focused on. You know, you knew about them. You kind of
Mhm.
recognize. You see the moon? Did you see the moon today? Probably
Yeah.
not. It's cloudy, right? But I'll ask you to look for the moon because one of the things you have to learn is the phases of the moon. And where is the moon? Where is the moon, right?
Yeah.
And it turns out it's very predictable, but it's a pattern that most people don't know about. So do you listen to the radio?
Yeah, quite often.
You
Yeah.
do. Oh, okay. Sometimes people don't. They're like Spotify or
Yeah. No.
YouTube or whatever, but you listen to the radio. Have you ever heard of people talking about the tides? Like sometimes
Uh-huh.
okay, wow, there's really
It's
big
based on
tides.
it's based on the either the moon or the sun, one of the two, and how it's like positioned.
Actually, would you believe it's both? It's really
Yeah.
both. Yeah, it's both the sun and the moon. Good job. That's great. You already know that. But a lot of times, you hear like, wow, there's really extreme tides today. And I'm thinking to myself, I wonder if they know any of astronomy, because if they knew the phase of the moon today, they would understand, right? So you will be
Yeah.
able to predict. You can predict for yourself when things are going to happen if you know a little bit of astronomy, which is kind of a fun.
Yeah.
Cool.
Yeah.
Great. Good.
Awesome. Yay. And I'm taking your lab in the fall too, because I
Okay.
know we can't
Wonderful.
take it over the summer.
Well, yeah, we just didn't know how to do it.
Yeah.
Hopefully in the fall things are a little bit more back to normal, but actually we're going
Yeah.
to figure out a way to do it no matter what. So we're going to find a
Okay.
way, no matter what, to have the lab, and then you will get a chance to use the telescope somehow. And we're working on how to do that. It may be really cool. You may get to use your own telescope, which would be kind of fun. But
Yeah.
I mean, it's yeah. Anyways, so have you taken a lot of online classes?
I have. I'm actually pretty good at staying
You're
on
pretty good
point
at
with
it?
online classes.
Okay,
Yeah.
so I need some advice. I need to know, how do I get students to make friends with each other in the class? How do I do that in an online class?
So I would definitely say the Zoom meetings are good. Like just make it mandatory for them to actually be in the meeting so that everyone has to like kind of introduce themselves and see each
Okay.
other. I know for my math class, because it was before it was online, I had friends and we actually made groups to
Oh, you
help each
did?
other out. And yeah,
What do
so
you
we
think?
actually had
What
a
if I just made groups to kind of ask you guys to work together? Do you think that might work a little bit?
it'll probably work.
Okay.
Definitely just like putting us in I guess a Zoom where you have to actually work together.
Yeah, yeah, yeah. They'll
Um,
give you a
and
task to
even
accomplish together. Yeah.
Yeah, and then even like the class meetings, like, okay, here's what's gonna happen today.
Mhm.
Um, Kind of get with your groups and set a time where you guys can meet each day.
Yeah, so that's part of the problem. I know everybody's got this different schedule, right? So not
Yeah.
everybody is free. Like somebody has a class right now, actually, from 8 to
Uh-huh.
10. One of my students is like, I can't make it to your office hours. I'm like, well, it was actually, I didn't know when to hold office hours, to be honest.
Yeah.
I'm throwing out a bunch of times, but
Yeah.
really, it's going to be up to you guys. When do you have the free time? When do you want to meet?
Yeah, I
So,
feel like a lot of the time, if you have like office hours later in the day, that all the classes are pretty much done. Like you don't have
okay.
to worry about it later. I know like for my classes are always in the morning, so they always started at 8 and then always ended at like 10.
Okay. Yeah,
So
yeah.
that was
That's
kind
usually
of
what I would do during the summertime when I would teach the lecture class. I like to get it done
yeah.
and just
Yeah, so
teach.
I think like the later time, like in the afternoon, like maybe at 4 p.m. or like a little
Okay.
bit later than that would probably work a lot better.
So I think after my office hour, I'm going to send you guys a little questionnaire. And one of the questions is going to be to highlight some times during the week that you would be available. And then
Okay.
we'll try to figure out, yeah, how do I do that? I'm gonna have to give you guys some group projects. I have some really fun little projects we're gonna do though.
Oh,
Um,
yay.
yeah, no, actually, I think it's so cool. Actually, I did something I've been wanting to do for years last night to try to prepare for you guys, and I'm so excited. It's really awesome. Like, I mean, again, things that I understand and I know about, but finding the
Yeah.
tool to allow you to see them, right? So how do you track the
Yeah.
stars? How do we don't have, we only have
Yeah.
6 weeks. So what if I asked you to watch the sun for a year, right? How could I do that?
Yeah.
Right? But I'm going to ask you to do that, right? You're going to watch the sun for a year. Okay.
Yeah.
You see a
Yeah.
problem with that? We only have
Yeah.
six
That it's
weeks.
like we don't have a year.
Yeah, so I'm gonna ask you to learn how to use some of the tools that we can use. Actually, would you like to see one of our cool tools?
Yes.
It's so fun. Oh man. Okay, actually, I'm gonna show you. Let me see if I can get this to work. I have a second camera here, and one of the things we don't do a lot of math in this class, but maybe a little bit, a little tiny bit. Yeah, not a lot actually, not a lot of math. I got a little side camera here, and then I could like write on the board. Can you see it?
Yeah, I can see it.
Okay. Okay. So actually, let me see. I go ahead and oh, through the speaker. Hold on. I gotta pin myself. So let's say, do you know how many? Is this upside down to you? It's upside down, isn't it?
Yeah, it is. But it's okay. I can read.
Hello? No, it's upside down. I put the camera up upside down. Okay, there we go. Is that better?
Yeah, that's better.
Okay, that's funny. Okay, so let me ask you a question. Do you know how many seconds there are in a minute?
60.
Okay, so you already knew that. 1 minute equals 60 seconds. Which one's longer, 1 minute or 60 seconds?
They're equal to each other.
Of course they're equal to each other, right? That's like silly. Okay. So what about what's a day? What's 1 day? How many seconds are there in a day? Well, you might not know that, but do you know how many hours there are in a day?
Well, there's 24 hours in a day.
24 hours. Okay. So we're getting closer, but that doesn't work, right? I mean, how do you get from hours? We need something else, right? How do you get, what's an hour?
60 minutes.
Okay. So have you done this before? Have you done conversion before?
Yeah, a little bit.
Okay, so we don't have to do a lot of this, but I just want you to know the elementary way. How do you figure out the number of seconds in 1 day, right? So the answer is that if you take a number, any number, how about 3.14? Does that number ring a bell? What's that number?
It does ring a bell.
3.14, 15926. Anybody recognize that number? You don't recognize that number? It's called pi.
Oh, the pi method. Yeah.
Pi. Pi. You remember pi?
Yeah.
Okay, we need that number later. But anyways, what happens if you multiply by 1? What do you get? When you multiply by number, does it change anything?
No.
No. When you multiply by 1, you get the same number, right? So the special thing about 1 is it doesn't change the value of a number, right? 1 does not change the value. Doesn't change value. The value, right? The value stays the same. But the funny thing about science is every number that we use is going to always have a unit to go with it, right? It's always got to have a unit. Otherwise, it doesn't make any sense. I don't know what that number means. Like, what if I told you I'm going to pay you 100 per hour? Would you be interested in that job?
Not really.
$100
I mean,
an hour?
Yes.
Okay, $100,000 an hour? What would it take to make you interested? Okay, all right.
Yeah,
What if I just said 100 per hour? Are you interested? And then I tell you 100 pennies per hour. Are you interested? Not anymore, right? See, without the unit, you don't know what it is, right? So it's kind of like you got to pay attention. All right, anyways, I'm not going to cheat you. Don't worry, I would pay you a fair wage. Okay, so let's go back to a day, right? We have 1 day. And the question is, how many seconds are there in a day? What we're going to do is multiply by 1. And what happens when you multiply by 1? You don't change the value of something.
No.
Okay, so what we want to do is change the unit. So one of the tricks in math you probably remember is that if you had minutes over minutes, what happens? They cancel out, right? Whenever you have the same thing on the top and the bottom, they cancel. So if I have day, it turns out the day is really going to be on top of the fraction. And the way that I'm going to get rid of it is by putting it on the bottom. I'm going to put day down here. Now, I'm not going to go straight to seconds. I'm going to go to what I know, which is day and hours, right? I know that there's a relationship between days and hours. I'm going to put hour. I'm going to abbreviate H for hours. What do we abbreviate for seconds? S for seconds. Actually, I think I have to use min for minutes,
Yeah.
right? Okay,
Mhm.
that's pretty much, I could have used D, I guess, huh? I could have used D for a day. But anyways, I wrote it out. So now what we're going to do is we're going to put in how many hours is the same as how many days. And so I'm going to fill in the numbers that go with it. Now, which one's bigger, 24 hours or 1 day?
They're equal to each other.
They're the same, right? Exactly.
Mhm.
They just look different, but in fact, they
Yeah.
represent the same amount of time. And so this number, even though it doesn't look like it, is really the number 1. That's it. And so it can't change the value. All it's going to do is change the way it looks. So we cancel that off, and you see there's 24, right? But we're going to go ahead and keep going because we didn't get to our answer yet. We got to have seconds when we're done. So how do I get rid of the hours? Well, the hours is in the top. I want to put hours in the bottom.
Yeah.
And the relationship that I have is minutes right here. I'll put minutes in the
Mhm.
top. And so there's 60 minutes in 1 hour, and that crosses the hours off. And I'm almost done. I'm going to do one more factor, and this time I want to get rid of the minutes. So the minutes goes here, and the seconds goes here. And 1 minute is 60 seconds. Now, you probably already knew how to do this anyways, but I just want to show you this is a mechanism that you can use for anything in science when the unit that you have is not the same as the unit that you want, right? You want to change it from one unit to another. But now we have to do what this says to do. What does it say to do? Well, when the numbers are next to each other, what does it mean? You multiply. You multiply these together. And so we're going to multiply. And if you have a calculator, I have a calculator app on my phone, on my computer. Maybe I should just get that out. Well, I've got it. Yeah, I'll just do that. Yeah, that's actually what I'll just do that, right? I could do all these crazy things that I can do. Normally, I can't do them. But I'm going to do them right now. Let's see. I can share my calculator. Can you see the calculator?
Yeah, I can.
Oh, that's awesome. Okay, so 24 times 60 times 60 again. And so I have 86,400 seconds is 1 day, okay? So 1 day is the same as 86,400 seconds. Okay, so that's not a big deal. And you might be like, I could have done that without you, Sean. I didn't need your help. But the truth is that there are going to be things that we might want to talk about that are a little more complicated, right?
Yeah.
So for example, do you drive?
I do drive. Yeah.
You do, okay. Do you drive on the highway, the freeway?
Yes.
Okay, actually in other states, they don't call it a freeway because they pay money to go on the roads, right?
That's
So
weird.
isn't that weird? I know, who would pay
Yeah.
money? I'm gonna go for
I wouldn't want
free.
to pay for. Yeah.
I know, it's crazy. And then they pay money to cross over a bridge and things like that, right? So what's the speed limit on the 101? 101.
65.
65, okay. So in science, so it's 101 speed limit, 65 miles, I'm gonna write it all out, per hour. That's the whole thing, right? In science, when you see this word per, it actually tells you something. Do you know what it means?
Like it's a single hour.
It's divided by. That's what it means. That's what it means whenever you see this. So let's say if I told you you're getting paid $100,000 per hour, man, you're getting paid a lot. But you see,
Yeah.
I'm getting $100,000 every hour. Per hour means divided by an hour. Okay, so how do you write that in science, right? How do you write that in science? You write 65 and you put the miles on the top and you put the hour on the bottom. Does that make sense?
Yeah.
Okay, cool. So this is a unit, right? This is a unit. It's miles per hour. But it turns out it's not the unit that we use in science most of the time. We're going to be using the metric system, right? And so the metric system, a lot of times people don't like it because, especially in America, we don't grow up with it. But it's really a good system. And so I'm going to encourage you guys to adopt it and learn stuff that's in the metric system. And so one of the first things is the thing called the meter, right? What's the meter, right? It's a unit of distance.
Yeah.
Okay. How about the kilogram? Have you heard of that before?
Yeah. It's
Okay. What is that?
it's like close to a gram, right?
Well,
like the
it's
gram
a
system.
kilogram, which actually this
Oh,
prefix
mass.
means 1,000 grams, and it's the mass, right? And then
Yeah.
we're going to use the second. Well, we already know the second, right? That's the unit of time. So these are the three most important ones to use, and then we'll talk more about other ones. But if I'm going into the metric system, what would be the equivalent to miles per hour? And the answer is the equivalent
Distance.
would be meters per second, because miles is distance and an hour is time. Does that sound good?
Yeah.
Okay. All right. So what we're going to do is actually we need to know the equivalence, right? So you need to know, like, what is a mile, right? 1 mile, it turns out, is 1,609 meters. You don't have to know that. I'm just telling you, right? That's what it is. It's 1,609. It's also another way to write it is 1.609 kilometers. What is a kilometer, right? So this is a kilometer. Anybody know what that is? What's a kilometer? Kilometer, right? What's the prefix kilo stand for? It's 1,000 meters, okay? Kilo stands for 1,000. So what's a kilogram? 1,000 grams. 1,000 grams, right? So the metric prefixes, that's another, whole part of this that we probably need to review if you haven't done that in a while. Okay, so 1 mile
in
is,
a long time.
that's fine, no problem. Most of the stuff is going to be pretty easy. We're not going to do a lot of stuff. And then the last one is going to be, what's an hour? Well, we actually started to do that in the previous page. If you go back, right, we just did more than that. We did a whole day, right? But what if we just wanted an hour, right? 1 hour. Well, how many seconds are there in an hour? Well, actually, there's 60 minutes for every hour.
Yeah.
And there's 60 seconds for every minute. Okay, and so what do we get? 60 times 6. 6 times 6 is 36. Puts 2 more zeros. 3,600 seconds. Okay. So now let's convert miles per hour into meters per second. Okay. So I want to first start off by getting rid of the miles. So where do I put miles in my conversion factor?
At the bottom.
I put it in the bottom because that way it's going to cancel with the top. And I know that 1 mile is how many meters? You wrote it down already? 1,609, right? And then the second thing I need to do is get rid of the hour. Where do I put the hour to cancel it out?
You put it at the top.
This time it has to be in the top, right? So 1 hour goes in the top, and I want to turn it into seconds in the bottom. And you fill in the numbers that go with this. 1 hour is the same thing as 3,600 seconds. So the miles cancels with the miles, and the hour cancels with the hour. And what I'm left with is meters per second. So let's look at the math here. By the way, this 65 is on the top. It's always on the top. It's understood that it's on the top, right? So when it's next to the 1609, what do? Multiply or divide?
Next to, you multiply.
Multiply, but this number is down in the bottom. What do you do with that?
You divide.
You divide. Okay, so let's go ahead and get out my calculator again. And so you could try it for yourself. That would be the best thing to do. Actually, always try it for yourself. Never rely on me to do it for you. So let's go ahead and take 65. Can you see my screen right now? Okay.
Yeah.
Okay, 65. This multiply times 1,609, and then divided by 3,600. Okay, whoa, it's lots of numbers. Okay, so one of the cool things that we're going to learn in science is you don't have to write all those numbers down, right? In fact, only some of the numbers are meaningful. They're called the significant figures. And so I'm going to go ahead and just write down 29. That's good enough. Okay, so the answer is 29 meters per second. So was that too tough, or do you think you could figure out how to do something like that?
No, I can figure out how to do it.
Cool. Okay, so that's a pretty useful thing. And actually that's even harder than most of the math we have to do, to be honest. But anyways, that's kind of a useful skill to have. Okay. So let me just go ahead and switch back. Okay, so we just talked a little bit about how to convert, and numbers have units, and those are kind of, that's useful. Let's see, there was something else. So I'm going to actually do something else. It's pretty hard. Do you know scientific notation?
I haven't used it in a while, but yes.
Okay, so you're gonna have a little activity, and then to practice, and you don't have to do a lot. It's really, I don't want to scare anybody because we don't do a lot of it. But I'm going to show you numbers that are really big and they're really small. And if you try to write them in a standard format, it'll take you forever. I mean, really, it'll take you forever. It's just a waste of time. So we learned this new way of, not a new way, but we learned a way of writing numbers more efficiently. That's called scientific notation. So we're going to use that quite a lot in our class. And so it's just being able to recognize. I don't want you to worry about doing lots of calculations, but when you look at a number, I want you to know what it means, right? So there's really big numbers and there's really small numbers. So actually, let's take a look at, hold on, let me just see. I've got something for you. Let's see, I could go back to, sorry, I'm a little slow here. I should go back to our, I'm going to go back to our Canvas site because I actually have something. Ooh, I need to get going here because you guys are ready to go. Oh man, it's funny how quickly things just kind of sneak up on you here. I was thinking I had all the time in the world, but I don't. Okay, here we go. So let's go back to, here's our site. So the Canvas here, and let's see, what do you have to do so far? So we have our meeting, and I just put these random times, but what I'm going to do is send out a questionnaire today to ask you for the times that would be the best. And let's see, so we're going to have some fun. I really hope you enjoy this because I love this stuff. This is so much fun for me. And this is my job, right? Like my job is just to share with you and hopefully get you kind of excited. So it's just the best job I've ever had in my life. And blah, blah, blah. Okay, so yeah, there's this thing right here. Actually, I usually give you this whole presentation. That's my wife, Mary.
Oh,
aren't these beautiful steps? Did you see these?
Yes, I did. They're beautiful.
They're so cool. And there's a whole bunch of them. These are in San Francisco. And my brother's like, I gotta show you the steps. And I'm like, oh, and so we went and visited him last Christmas time. Actually, we saw there's actually more than this. There's so many more. But anyways, I have a PhD, and my degree is not in astronomy, but in physics. And if you're interested, I'll tell you all about that. But before I started working full-time, I was a part-time teacher, and I taught astronomy and physics. And then this is my 5th year as a full-time faculty. I love my job. And let's see, and I messed up. I forgot to tell you the new times. Okay, my job. Okay, so the deal is I am Dr. Kelly, or professor. But actually, because, okay, so again, it would be better if we were in person. So let me just look at you guys in person. And you're the only one here. How do I say your name?
Kaylee.
Kaylee, okay, never mind, that's easy, okay. But yeah, you threw me off because I hadn't seen that spelling before, but Kaylee, okay. So Kaylee's here, but anyways, the rest of you guys are here with us in spirit. One of the things that if we were in the classroom together, I would tell you that we have a job. All of us, we have a job. And it is the same job. And you think that my job is my job and your job is your job, but we have the same job. What is our job? And our job together is to lift you up. That is our job, right? Your job and my job and your job together is to lift us up. So in science, I want you to know something important. We don't care about titles. The titles are just there to let us know that they're, we spent the time and energy to get them. but the title is not important. What's important is the work. So together we have a job, and we are what we call collaborators, right? We are working together for a common goal. And so actually, I want you to know that you can call me by my first name. My name is Sean. And so I invite you to call me Sean. Sometimes students feel a little intimidated because I'm a faculty member, blah, blah, blah. I'm Dr. Kelly, but you could call me Professor Dr. Kelly, but you could also call me Sean, okay? Because we have a job together. And so as long as you remember that, and I remember that, we are doing the right thing, okay? So we're supposed to be working together and to make you the best we can make you, right? To lift you as high as we can go. There are no limits, right? This class is 6 weeks long. That's the only limit, right? But whatever you want to learn, I want to teach you. Whatever you want to learn, I want to teach you more than you want to learn. And you take as much as you can. But the idea is that we learn from each other too, right? So I have things to learn. I have a lot to learn. You've taken more classes than I have online. I'm going to learn from you. And I really hope that in the course of my learning, I can actually improve it for the future too. If we have to do this online teaching for a while, then I want to get better at it. I don't want to be, the same as I am today, which is pretty weak. Okay, so I'm hopefully getting better over time. Okay, so that's actually something important though. We are collaborators. Okay, so we work together. Let me go back to my screen share. Oh, I got to do this, Sean. Here we go. I'm going to be so sweet by the end of 6 weeks. You could call me if you want. Call me on the cell phone, not on my cell phone. But you could actually send me an email. The email is the best way to get me. Okay. Let's see. That's the about me. That's not very long. I actually have a whole slideshow. Maybe I'll show you guys that later. And then here's our course Q&A. Nobody has asked any questions, but if you have a question and you want to ask it here, I will look at them every single day and I will do my best to respond. And then finally, the most important part, these are the learning modules, okay? So what do we have here? So blah, blah, blah. Okay, course overview, it's pretty weak right now. I have the syllabus, okay? You could click on the syllabus. That's a download, or you could click over here and then you can see not too much, but this is our syllabus, okay? Actually, it's kind of boring. Again, I'm gonna improve that today. I want some pictures. Where's the pictures, man? One of the coolest things about astronomy is the beauty. And so, wow, actually there's no pictures on my page. Wow, that's amazing. But you do want to know, what do we have to do? We have a textbook. You need the textbook. You can get it from the bookstore. And if you bought the kit card, it is not required. It would have been required if we had a lecture because you would have gotten more for it, but I'm actually going to give you something. If you buy the card or not, I'm going to be sending you something. If you got the card already, I don't think you can send it back, so I'm going to give you extra credit for it. If you didn't get it, don't get it. It's fine. Don't worry about it this time. Normally, I would give you a lot of other things for it, and it's just not possible if you're not physically with me. Okay, so how does it work? We're going to have exams is 40% of your grade. So I want you to know that that's a big part of your grade, but these are actually worth more, right? So your participation, 20%, and your homework, 40%. Your homework is worth as much as your tests. And this is important to me because I believe in your work ethic, right? Your daily performance is more important to me than how you do on your exam. There are a bunch of tests, your tests, and so you can mess up a few tests here and there and it's not gonna really affect your grade in the end, okay? This consistency is the most important part, okay? So staying on top of the class, okay? So actually, I guess, is this useful to you, Kaylee?
Yes, it is.
Okay, all right, so then this is actually what I would have done in the lecture. And I guess I'm doing it for you and hopefully anybody who watches it afterwards. Okay, so we do have some student learning outcomes. This is what we hope that you achieve. Not hope, this is actually what I need to make sure you achieve by the end of the class, okay? So number one, describe the size and scale of the components of the universe. Holy mackerel, it's big. It's so big. But anyways, we're going to try to figure out the scale of everything, right? And then understand some models of celestial motion. Now, celestial is a fancy way to talk about the heavens, right? Anything that's above the earth is considered to be celestial. And here we go, predict the consequences of these motions. So not only understand the models, but be able to predict what those models tell you about what we should see, okay? Then next step, SLO2, student learning outcome. Compare and contrast various components of the solar system, how they form and how they relate to the Earth. Because we live on a planet, right? This is a planet, Earth, right? Are there other planets? Well, of course there are, right? How many planets are there? Do you know that?
Well, isn't there technically, so sun, the moon,
Is the sun a
Venus,
planet or is the
Mars,
sun a star?
Jupiter? Oh, no, it's a star,
Yeah, okay.
right?
So the sun is not a planet, but the solar system definitely has the sun, right? That's a big deal. And then we've got the
Yeah.
planets. And how many planets did you say? Do you know?
I haven't seen I haven't gone through the planets in a while. I would say there's at least 10.
Okay, all right, that's a good guess. It depends. But we're going to talk about, do you know if Pluto is a planet?
There's been controversy about that one, but I believe it's a planet.
Okay. So actually, we do call it a dwarf planet now.
Yeah.
And I'm going to be teaching you all about that and why we call it a dwarf planet. So if we don't count Pluto, then right now there are currently 8 planets and then a number of dwarf planets. And that's actually a big deal. But anyways, are they like the Earth? Well, that's kind of the big question, isn't it, right? Are they like the Earth? Have they ever been like the Earth? Will they ever be like the Earth? That's actually a question that we ask all the time. So we're going to compare the planets to Earth. It's called comparative planetology. And then the third one, use the components of the electromagnetic spectrum. Do you have any idea what that is?
No.
You don't. Okay. So actually, I'm going to pause for a second because this is a big deal. This is a really big deal. In fact, I would have told you 5 years ago that it was the only thing that we had from space, right? The only thing we could see, right, is electromagnetic spectrum. That's the only thing, right? Do you have any idea what it is?
I know it has to do with electricity.
Oh, that's good. Yeah. Electric, right? Electro, and then magnetic. That's magnetism, right?
Yeah,
and then
which is
there's a word
connection.
Yeah, electromagnetic spectrum is a fancy way of saying light. Okay, light. Electromagnetic spectrum is light. But we will learn that there are actually 2 kinds of light, right? The light that we can see is called visible light, right? And the light that we can't see would be called invisible. Okay, so how much of the light do you think we can see and how much do you think we can't see? Have any idea? And by the way, this is probably wrong, but it's just kind of a roughly.
I would say it's more invisible than visible.
Exactly. So would you believe it's probably not even right, but 2%?
I would say, yeah, it's about 2, and then the rest
You get that idea, right? Most of the light that we are able to see now is because we have cameras that allow us to see it. It is not visible to the human eye. But anyways, electromagnetic spectrum is light. Okay, so that's actually a really big deal. Up until a few years ago, it was the only way we knew anything about the universe. Okay, so I'm just teasing you right now because I'm not telling you that we have new ways of understanding the universe, but they're new, they're brand new. They're not even they're just now starting to come into textbooks, right? We actually have a new version of your textbook we're going to be using in the fall, and it now has something new, which I will tell you about. It's just not in your book yet. Anyways, okay, so we're going to study light, right? Translate light to investigate stars and stellar evolution. Demonstrate how stars, nebulae, you know what that is? Nebulae, another word. That's a plural.
Same for nebula. Isn't it multiple nebulas?
Exactly. So what's a nebula?
Oh,
A word, right? I mean, a vocabulary.
yeah,
Maybe you don't know it. Do you know what nebula is?
not quite yet, but
Okay,
I know
that's
a
cool.
nebula has to do, isn't it like an atmosphere almost?
Up close, it's actually going to be it's going to be a nebula is going to be glowing gases. Okay. So what does glowing mean? Right? There's light.
Flashy.
Light comes out of them, right? Good morning, Raymond. Thank you for joining us.
Good morning.
How you
Sorry
doing?
I'm a little late.
Yeah, this is just no. It's just our office hours, so you could drop in anytime.
Okay.
But actually, Kaylee is like, actually, she's not asking any questions yet because she doesn't have too many yet. But so we just started talking about the course and things that you're going to find on Canvas. So I'm recording this meeting as well. So you can always go and watch it later, and I'll post a link later in the, for people to be able to watch it. I
Okay.
can post that now, as a matter of fact, but I'm with you guys right now. So maybe right after the meeting, I'll post it, I guess.
Okay, so I'm very new to this. I'm just gonna sit here and just listen to what y'all have to say, if that's okay.
Sure, absolutely. Yeah. No, actually, I'm new to it as well. So just so you understand, the goal is to have you guys learn and get excited about this knowledge in astronomy. But, I'm here to facilitate, right? So I don't have all the answers. I just hopefully have enough that I can, answer your questions when you have them. But this time, the office hour time is when you can come and ask questions or discuss concepts with me. And, I'm happy to do any of that with you. Okay.
Okay, thank you very much.
Sure thing. Okay. So we're going back to the student learning outcomes then. We'll go ahead and continue with that. All right. So we're talking about stars, nebulae, galaxies, and quasars have been used to explore the concepts of relativity and cosmology. Okay. So those again are some words that you may not know. Do you know what relativity is? Anybody?
Yeah. It could be explained a little bit more to me, but I mean, I know the basics.
You've heard of that? Okay, so who do you whose name do you associate with relativity? One guy in particular. His first name is Albert
Einstein.
There you go. That's it. Yeah. So relativity would be Albert Einstein. And we'll talk about not just one theory, but two different theories of relativity. That's going to be a little bit later in the class. And it's really amazing. Unfortunately, it will tell you that you don't understand the universe very well. Same with me. I don't understand it very well. But anyways, it's an important insight that we have about the way things work. And then what about cosmology? What do you think that word means? Cosmology.
Study of the cosmos.
Cosmos.
Yeah.
Okay, that's good. So actually, it's going to be specific to the large scale structure of the universe. And usually, I don't have enough time to get into much detail with that. But in this online forum, I'm going to give it a shot because, this thing, first of all, you guys are expected to be a little more independent and kind of be structured in your learning. So I'm going to try to support that, but it'll allow me to go a little bit further maybe than I would in a typical face-to-face class. Okay, so we'll see how it goes, but that would be my goal. My goal would be to study a little more detail than I usually do. What's the big picture? How did it begin? In the Big Bang, right? You know about the Big Bang. And then where's it going from here? What's going on right now? Do we see any clues about the evolution of the universe? And the answer is yes, we do. But I won't tell you that yet. Okay, so let's see, DSPS. If you're a DSPS student, make sure you get your needs taken care of, contact them, get tested. And this is the first time I put it in Spanish, but why not? Put it in Spanish too. If Spanish is your primary language and I speak in English all the time, I understand that's going to be a little bit harder for you. So please let me know if I can if I can support you in some way, if there's a way that I can do that. The lab is not currently available, but it will be in the future. And so if you need the lab, with the lab, sorry, this class becomes a lab science. So if you need a lab science as part of your transfer requirement, for example, then you want to take the lab, and you can take it at any time in the future. So we don't hold the lab on campus. It's held at the Santa Barbara Museum of Natural History. So in this current situation with coronavirus, the museum is actually closed. And we also didn't quite have a strategy for dealing with the lab in this situation, but we're hoping that in the fall that things will be at least a little bit better, and we will have a system in place for you to take the lab. So you should plan on being able to take the lab if you need it, and we're going to figure out a way to do it. In fact, that's part of what I'm going to be doing this summer, is working on how to do the lab, even if we have to have social distancing measures in place. Okay, so we're going to do pretty much everything you need is going to be on Canvas along with your textbook, and I will use Pipeline email otherwise, and you need to participate. 20% of your grade is participation. Okay, so Kaylee gave me some clues already. I'm going to need to group you guys up, and you're going to be working with other students in the class. I'll tell you more about that. Maybe not today, but in the next couple days, we'll be starting to group up, and I will have a way for you to work with each other. And actually, I should have mentioned student learning outcome number 4, make new friends. Okay, I would love for you to meet some new people in this class, and maybe even make some new friends. They could be people that you just study with for this class, but definitely talking about the ideas is going to be part of the way that you integrate the information into your brain. Okay, so share this information with your friends and your family, and definitely, especially with the more difficult material, please talk with your classmates about it. Okay, and the more you share it, the more you're going to understand it. Okay, teaching someone else is probably the best way to know that you understand something. Okay, so anybody who doesn't show up in the first couple of days of class, I'm going to drop you, because I have a huge list of students that want to be in this class. And unfortunately, I decided I'm not going to be crazy and accept way too many people. I'm going to make this a nice small class so I can give each and every one of you some attention. And that means you and I are supposed to interact with each other. I'm supposed to get to know you. And I don't know how you feel about that. Maybe you took the online class, because then your teacher doesn't get to know you, but that is not going to work with me, because I want to get to know you, and I want to know how I can help you. So please be honest. This is honor and integrity. Be honest. I can't stop you from using material on the test. I'm not going to do a proctored test. So you can use your notes when you're taking your exams, but please don't rely on other people. Please don't let anybody else do the test for you. And please don't communicate with other people when they're taking the test, okay? It's meant to be your own work. If you want to get ahead, you can read and you can watch videos ahead of the schedule. The schedule is just a suggestion. So now, again, we're gonna do a little bit more than the typical lecture class, and I am gonna try to follow the schedule. If it doesn't work, it doesn't work. And I'm gonna go ahead and scale back, but we're gonna give it a shot, okay? So this first week, we're going to try to cover chapters 1 through 3. That's a lot of material, but you signed up for it, right? So part of the thing to recognize is a summertime class is very rigorous, right? It's a time-intensive thing. But on the other hand, you get it done in 6 weeks instead of 16 weeks. So just be ready, be prepared to put in that effort, and you're going to do great. I really believe you can do it. Actually, I know you can do it because I've seen students do this in the past, okay? In fact, summer students are typically some of my best students, okay? Because you have to be disciplined in order to stay up with the material. You have to. You cannot fall behind. There's no time for that. So you need to stay on top of your game. And by the way, that's the best way to do this course, right? So today, you want to be on top of your game. Today, you read chapter 1. Right, today, read chapter 1. Take notes on chapter 1. Now, I want to mention. Does anybody not? Raymond, do you have the book already?
I do not have the book.
Okay,
It's
so-
on its way.
Okay, listen, you can get a copy of the book today, right now. And I want to show you how to get access to that actually. Why don't I show you how to do that?
That's the one that's online, right?
Was that? Yeah,
Is it-
online. You
Oh
can get-
yeah, I have that one. I already went and got.
Okay, good. Okay, you know how to do that then. But for anybody who doesn't know, there is, because of coronavirus, the publisher has given access to our textbook. So let me just show you how I would do that. So it is called, let me just get that up. Open a new tab for you. Okay. Okay, so if you don't have it already, you're going to go ahead and you're going to go to the website. What's it called? Vital Source Bookshelf. Bookshelf.vitalsource.com. There it is. Bookshelf.vitalsource.com. Now it already logged me in, so you can't see me logging in. But anyways, if you don't have an account, you're going to go ahead and make an account. And you make an account. Make sure you use your Pipeline email address, because this way they know you're an SBCC student, okay? And so when you sign in, you can then search for textbooks, and actually you can find other textbooks too, but you would search for astronomy. Okay, search for astronomy, there it is. And actually it doesn't look like they have any other books. Okay. Oh, they do, they have more books, but we don't need all of those books. What the heck?
Oh, they're going to your mom's too.
I didn't realize they have all these books. Okay, here's our book, and you can actually get to it for free right now. I don't know how long it's going to last, by the way.
Okay.
So
I'm
you
not
want to
watching
make,
it today?
sorry, what was that?
I think it might be till like the 25th of this month. I think I read something about that.
Okay, so you have at least at least 1 week. Okay, you do need to get a copy of the book then. They also it may last a little bit longer because the whole situation has changed. But anyways, you can get to the first chapter. You can start reading the first chapter. Now, we picked this book because this guy actually is kind of entertaining to read, and he writes for different people like Scientific American and the New York Times. He writes for different science columns. He has a blog. If you follow him on Twitter, you can find him. But anyways, Getting Started Astronomy and Being Human, okay, is the first chapter. It's 20 pages long. Okay, so you want to be able to read the first chapter. So the first chapter is just a little introduction to science and some of the ideas of science, okay? So we're going to try to get through this whole book, man. How are we going to do that? We're going to give it a shot. And like I said, if it doesn't work, it doesn't work. But I'm going to skip past the preface here. I should have just gone straight to the table of contents. How do you get to the table? Here we go. Getting started. Here we go. Miles, go to one. Getting started. Oh, that's a pretty picture. Speaking of pretty pictures, man, I forgot to tell you guys something else. This is the astronomy picture of the day, right? It's called APOD. Let me just put that in. APOD, right? Astronomy picture of the day. Literally every day is an amazing picture. What? This today is a video clip, right? I don't know what this is, but I'm going to just watch it. It's a 1 minute long. It is, this place is amazing. And so, and in fact, we're looking at, that's a nebula. Ooh, we were talking about nebula. Whoa, we're zooming in. Oh, this is awesome. So they figured out the locations of the stars, and we're zooming into this nebula and star forming region. What? This is crazy. Oh, I love it. Oh, beautiful. So what color do you guys see? What color are those stars right there?
Kind of like
Can you see blue? They look very blue to me. They look
It
blue.
looks like a purple blue.
Yeah,
Yes.
good. So we're going to learn that blue means hot. They are hot. They're young stars, and they're going to die very quickly. Wow, this is amazing. So there's some three-dimensionality, right? They're trying to show you the structure. How do we know this? Isn't that amazing? Oh my gosh, that's amazing. That is amazing. That is cool. Okay, so this is, what was it called? The Reef. It's called the Reef Nebula. Okay. So anyways, this place will never make you sad because there's something new every single day. Like I just go to yesterday. What? Whoa, that's a water spout. That's from Earth. Water spout. Whoa. Okay. So every day is something new. Man, you could never get bored with this place. So anyways, just take a look. But it's really beautiful too, right? There's another, this is this concept of nebula. So what color do you see?
Purple.
How about
Yellow.
down here?
Blue.
Yeah. Okay, I see blue up here. I see purple. I see orange, maybe even
Yeah.
some red, but I can't see the red so much, right? So there's going to be different colors of nebula. That one's kind of reddish purple, right? And so that's going to be something that we learn about. Anyways, you go to this textbook, Vital Source. You can read the textbook, and you know this is what we need to do. So actually, he starts talking about this place. This is actually really cool. And if we were in the lecture, I would tell you how I went there a few years ago. I finally went to Ireland. My last name is Kelly, right? So my ancestors came from Ireland. And actually, 3 years ago, my wife and I and my son went to Ireland. I was going to track down my ancestors. This is a dream finally coming true, right? And so I go to Ireland, and I didn't have a lot of information. I knew roughly where my mother's grandparents came, great grandparents came from. They came from the south of Ireland. I had a wedding certificate. I'm sorry, marriage certificate. And then from my father's side, I didn't have very much. I had my last name, right? So I was amazed. I went to Cork, and I found the church where my great grandparents got married. I stood in that church, looked around, it was amazing. And then I went to where my father's family was from, and I discovered that Kelly is the second most common last name in Ireland. It's like Smith, right? And so everywhere I went, I was meeting Kellys, and none of them were my relatives. But anyways, so I didn't learn as much as I thought I was going to learn. But anyways, it's kind of a funny thing. But I went to this place. This is called Newgrange. And Newgrange is an ancient, right? It's like a couple thousand years old. And 5,000 years old. Oh man, I was way off. 5,000-year-old monument. And what is it for? Well, the answer is we don't really know. Okay, is it a burial mound? Well, they did find a couple of bodies inside, but it's not a burial mound, right? There's only 2 bodies. But there's a very interesting structure to it. It's got a long corridor. You have to, actually, there's a rock right here. You have to bend down underneath the rock. And this is a big, like a skylight where the light comes in. And you bend down and you go through this corridor, and it's about 50 feet long to the center. And in the center is a round room. And in the center of the round room is a ceremonial bowl, right? And that's where they found some of the bones. And they think that it was probably some kind of a ritual where you would bring the body, but you wouldn't leave the body. It would just be there temporarily, you know, for some kind of a ritual. But something kind of amazing happens in this place. In the days near the winter solstice, we'll be learning about that date later. It's one of the important astronomy dates. Actually, does anybody know the winter solstice, what that is? What's the winter solstice? Anybody know?
December.
It's in
It's
December.
usually in December.
December 21st, pretty close to December 21st. So it is the longest night of the year or the shortest day of the year, right? The least amount of
yeah.
Right? So the winter solstice, on the day of the winter solstice, the sunlight goes straight up this corridor and illuminates the central chamber for about 14 minutes, but only on that day or around that date, okay? So this was built according to the sun, right? This is an astronomical place. This is aligned with the sun, right? So there's actually going to be, all around the world, there's going to be situations like this where ancient people watch the sun and notice the sun. I've actually got a slide set too. Let me go ahead and not do that. But anyways, the book is there. You guys can read the book. Take your notes. Take notes on the book. If you're a good student, part of what you want to do is try to find the most important information. So when you read a paragraph, what was most important? You don't write everything down. Don't highlight everything. Write down just a few things if you can, because you're trying to trigger your brain to remember the process of reading the book. Okay, so reading is a skill, a really important skill for our class and for any other class that you take. And so part of it is taking a lot of information and finding the essential pieces of it, right? So I can help you with that if you need help with that, but I am expecting you to try to do that. Okay, let me show you something else on our Canvas. And actually that's kind of what we should be looking for. Okay, let's see, going back to Canvas. Let's see, going back to Canvas. Here we go, going back to Canvas. Okay, so if you click back to home, or actually you could have just done modules. Let's go to modules, right? We're down here, we're week 1. Okay, so there's more stuff. I have to add some more stuff today, but more stuff. Oh boy, you're gonna have a lot of stuff. Oy, got a lot of stuff. Anyways, record a short video telling us about you. Okay, so this is actually number 1. I'm looking for, oh, we got some videos. Oh, I can't wait. I can't wait to see these. Okay, so anyways, record a video. And in this video, tell me your name and then tell me what your friends call you. Tell us, not just me, right? And then tell us a question that you want answered. Now, you may not have a lot of questions right now. That's okay, don't worry about it. But if there's something in your mind right now, I'd like to know what that is, right? What's a question you want answered related to astronomy before the end of the class? Now, it's very likely that we will answer your question, but some of you have questions that I don't know the answers to. And so the answer is, I don't know the answer either. I have that question as well, maybe, but I'd like to know. If you have any questions, let me know what they are. Okay, and then third, tell us a fun fact about you that somebody might not know, okay? And it's not a big deal, but I did it for you. You can watch my video. You can see what I like, what I did, and that's actually what I'm looking for. And it looks like we have a couple of people that have done this assignment, and I'm gonna go ahead and watch those in a few minutes myself when I'm done with the office hours. Okay, that's our first assignment. Number 2, let's see. Oh, extra credit. Okay, check this out. If you see the words extra credit, you should always do it because it's usually not that hard, and you never know. You might need a few points. That few points will bump you up, okay? But look at this one, the easy thing right here. What do you have to do? Nothing is better than extra credit. So here's what you do. In order to put a name to your face, I would like to ask you to post a recognizable face photo to your Canvas profile. Nothing fancy, but something that helps me to put it, helps us, not just me, right? Then add a brief biography to go with your face. What would help us to know, help me, but not just me, just all of us, okay? And if you don't know how to get to it, here's how you do it. You click on the account over here. Okay, so if I leave the student view, okay, so how do you get the full points? You got to do both things, right? Upload a picture and add something interesting that tells us a little bit about you. Okay, that's worth 5 points. That's extra credit. Extra credit, that's the good stuff. Okay, now I have study guides here, and actually I would advise you to download the study guide immediately, right? Before you read chapter 1, actually. And the reason is that I built these study guides to help show you exactly what I'm looking for, okay? There's a lot of information, too much, right? So I want you to consolidate. I want you to figure out what's the important information. And so I'm gonna do that in 2 ways. Number 1, the study guide. But number 2, I'm gonna be giving you, today I'll give you the quiz for chapter 1. And if you do well on that quiz, you know you got everything you need to know. But if you didn't do well, you have to go back and try to review that material. Now, the cool thing is the little quizzes I'm going to give you are supposed to be low stakes, meaning you shouldn't feel pressure. This is something where you get to do it again, maybe even 3 times, maybe unlimited. I haven't decided yet. But the idea is you want to do that work, and if there's something you didn't get the first time, go back and try it again, okay? And then you'll take a test, okay? The test, I'm not gonna actually have it available today. You don't wanna take it today anyways. Give it a day or 2. to kind of solidify in your brain. And then after a few days, we're going to go ahead and give you the test. Okay, so you have time to try to absorb that material. I think the first test maybe won't be due until Monday, actually. I'll give you a little bit of time. But the idea is to try to get the information and feel more comfortable with the information, and then take a test to kind of show that you really got that information. Every test is going to be a 20-point multiple choice test, and then a short essay. Okay, and the short essay allows me to hear your ideas and how you're developing your understanding of the astronomy. Okay, so anyways, let's take a look at that study guide. I just downloaded it, and I'm going to go ahead and come back and screen share again. So here you go, the study guide. This is what it looks like. Okay, so the study guide. No, can you see it big? It's not looking big. All right, let's go big enough. So it's one page, actually not even a page. There are some definitions, right? You should know the definition. So you need to write down definitions. If you already know the words, don't worry about it. Scientific notation, order of magnitude, planet, star, planetary system, galaxy, galaxy supercluster, galaxy cluster, galaxy supercluster, universe, right? So astronomical unit, a light year, a parsec, scientific method, hypothesis, theory, pseudoscience. Okay, so those are some words that you need to know the definition for. And then down here, be able to. These are skills that you need to have by the end of chapter 1. Okay, so change between ordinary and scientific notation. Okay, determine the order of magnitude of a number. Add, subtract, multiply, divide. Now, again, we're not going to do a lot of math. I'm only making sure that you have the basic essential information. Okay, we're not going to do a lot of it, but I think you should be able to do it. Okay, organized by size from a subatomic particle, atom, dust, single-celled organism, planet, star, planetary system, galaxy, galaxy cluster, galaxy supercluster, universe, right? These are in order by size, okay? So you're starting off with the smallest things are called subatomic particles. And then we have atoms, which are little pieces of matter. A dust is actually pretty big compared to an atom, has, you know, lots and lots of atoms in it. A cell is a pretty large thing actually in comparison to dust. And then jumped all the way to planet, right? And then a star is much bigger than a planet. A planetary system means a solar system is bigger than a single star. A galaxy has billions of stars in it. A galaxy cluster can have 100 galaxies in it. A galaxy supercluster may have millions of galaxies in it. And then, of course, we get the size of the universe, okay? The steps of the scientific method, you should be able to state them clearly. Actually, that's all of this is in chapter 1, okay? And then what's the difference between a science and a pseudoscience? For example, astronomy and astrology, right? So astronomy, astrology. So they actually stole the word. Astrology is the word that says the study of the stars. But in fact, astronomy, it was already taken, right? So horoscopes and things like that. And astronomy, the naming of the stars, became the word that we use, okay? And then here's a few things, it's never gonna be a lot, but a few things that you need to memorize, okay? So you need to commit this to memory. What is the size of the Earth, okay? So we have the radius and we have the diameter. And it's this and this, okay? And then the size of the moon is 1/4 or 25% the size of the Earth. And the order of magnitude difference between the sun and the Earth is about 10 to the second, okay? So we'll come back to that in a you know, actually come back to that. You need to be able to do that. So after you read the chapter today, you can say, how much of that do I already understand? And then what do I not understand? What do I still need to learn? And so the goal is that that study guide helps you kind of hone what information you really need. Okay, so actually, since you guys are here, do you want me to show you something with the Earth real quick? Like real quick?
Yes, please.
Yeah,
I
sure.
mean, why not, right? I mean, it's not a lecture, but you know, I could show you. All right, so the Earth is a sphere, right? Actually, have you heard about the people that believe the Earth is flat? Do you believe that?
Yes.
I can't believe that. How could you believe that? I mean, really?
We'd be
Actually,
falling off right now.
I don't know.
I don't know how they could believe that. It's
I don't understand this. Okay,
Yeah.
actually, by the way, I again, if we were in class, I would do something else too. But let's see. I just show you right now. Anyways, I should show you a couple ways, but let's see. Let's go ahead and click here. I don't know if you guys know, but there's something called the ISS. That's the International Space Station webcam. Okay, and here it is, nasa.gov. You click on this, and this is a live image from space right now. Is that crazy? You can look down on the Earth from space right now. This is a big sphere. Hello, right? This is orbiting the Earth once every 90 minutes, which is kind of crazy. 400 miles above the Earth. My wife and I saw it last night. Mary and I, we went outside to watch it go over. It's kind of cool. It looks like a star, but it moves, right? And it goes across the sky pretty quickly. It takes about 5 minutes, 4 or 5 minutes to cross the sky. But this is the view from the ISS looking down at the Earth, which I think is just amazing. We are watching live. Only 900 people right now. But anyways, this is the Earth. We live on a big sphere. And yeah, anyways, okay, so take a look right here. So we've got this big ball we call the Earth. That's the Earth, right? Okay, so there's the Earth is rotating, right? What's the point at the top of the Earth called? The North Pole?
Yes.
And there's down here, there's called the South Pole. What do you call the line that goes around the middle of the Earth?
The equator?
The equator. Okay, so now we got a little quick, simple picture, right? So this is north, right? Up here is north, down here is south. Do you know which way is east and which way is west if you look at this picture right here?
Is east where it's pointing towards the equator?
Yes,
Or
it is. That's east. And over here is west. That's right. That's the directions that we know and love, right? They're kind of useful. All right, so now here's the thing. The Earth is a big ball, right? And we know that it's actually rotating. Do you know which way it rotates?
West to
It's
east?
rotating towards the east, right? I'm gonna write that down, right? Earth rotates toward the east. That's the way it rotates, okay? Actually, do you know how long it takes to rotate one time?
No.
Yeah, you do.
365.
No, wrong answer. Listen, have you heard of that thing called the sun?
Yeah.
Yeah, how often do you see the sun? All the time?
No.
So the sun goes through a cycle, right?
24
Why does the
hours.
sun? Yes, there you go. Every 24 hours. There you go. That's right. So we have day and night because the sun is not moving. It's the Earth rotating, right? So the sun comes up and goes down because of the rotation of the Earth. It happens every 24 hours, right? You know that. You know that. Everybody knows that, right?
Yeah.
But actually, back in ancient times, they didn't know that. They didn't understand that. They believed that the sun rose and it set. Actually, there's some great stories, right? The sun was a god, and he rode, or she, usually a man. I don't know why, but the sun god Ra in Egyptian culture, or in Osiris. Sorry, Ra. No, Ra was the sun god. But anyways, it rode across the sky in a chariot, right? That's kind of a fun story. So, what? Do you guys hear sound? Oh, do you hear that sound? I just realized what that was. You know what I left on? I left the ISS on, and they're actually talking to mission control.
I hear that.
Can you guys hear that?
Yeah.
Like, who's
I can hear
talking? That's the International Space Station. Okay, I'm gonna go ahead and close that up because it's so cool though. Man, I love that. That is so cool. Anyways, ISS, they're talking live. Okay, so the sun is rotating. Sorry, the Earth is rotating. We see the sun rising and set in 24-hour cycle. But here's the deal. So there's a point in the middle of the sphere, the center of the Earth, right? That's the center of the Earth. And so the distance from the center to the edge is the radius, right? That's the radius. And so what's the radius of the Earth? Well, you need to memorize. And so this is a number you need to memorize. You need to memorize 4,000 miles. You need to memorize that, okay? So the radius is from the center to the edge, but what do you call the distance when you go all the way from one edge to the other across the sphere and go through the center? What's that called? Anybody remember the number, the name? Diameter, right? The diameter goes all the way across. So the radius is just half of the diameter, right? The diameter, so the radius is 4,000. What's the diameter? It's going to be double this, right? 8,000. 8,000 miles. Okay. And you're going to have to also learn the metric system. Okay. So it's not to hurt you, but just so you understand, we like the metric system better. And there's a reason. It's really a better system. Okay. So it's not something that we grow up with in the US. And, you know, we learn it a little bit, but we haven't really jumped on board. Now, actually, again, if we were in the lecture, I would tell you a little story. It turns out in 1789, there was a mission from France to come and convert the US to the metric system. And everybody was ready to do it at that point in 1789. And then the minister or the ambassador who was coming to do it died along the way. And so he didn't make it to the US. But we would have actually converted in 1789, and we would have the same system that everybody else in the world has, right? But anyways, in the metric system, it is 6,400 kilometers, okay? So what would the diameter have to be? Well, you just double it, right? So instead of 6,000, what would it be? 12,000 and then 800 kilometers, okay? So that is something you have to memorize. Now you don't have to memorize, and actually I probably shouldn't do this, but because I'm going to end up doing this again, but you know what? Sometimes when you hear it twice, it's better. Did you ever notice that? Like the second time you get more than the first time. So this equator right here is a big circle, right? It's a big circle. So one of the crazy, amazing things that we can do is we can say, hey, how big is that circle? Does anybody know the name? Do you remember the name for the distance around a circle? How big is that? What is it called? Remember the name mathematically? Called the circumference. Remember that word, circumference?
Yeah.
Okay. Now, do you remember the formula for the circumference? Anybody?
I do not.
You don't. Okay. So I'm going to remind you. You probably learned this at some time. It's pi times the diameter. Does that sound familiar? Or 2 pi times the radius. So this is not exact, but it's close enough for our class, right? Actually, we're going to talk about that a lot. I'm like, do you want to be super precise? You want to be my friend, or do you want me to do it right? No, I mean, that's not what I want to say. Is it close enough? And for us, we don't have to be perfect. We can be close enough, okay? So when I say pi, do you know what the value of pi is?
3.14.
Yeah, 3.14, good enough, okay? But what if I told you that that's actually more than you need? as a matter of fact. It's close enough to use 3. Close enough. Good enough. If you want to be more careful, that's fine, but that's close enough. So what about the diameter? Well, usually I would use the kilometers, but it turns out it's so easy. I want to use the mile because it's going to be so easy, okay? So what is it? It's about 8,000 miles. And so what's 3 times 8? 3 times 8.
24.
24. Okay, so 3 times 8 is 24. You get the circumference of the Earth. The distance around the equator is about 24,000 miles. Okay. All right. Good. Now, we don't do a lot of math in this class. We only do a little bit of math. But I would like you to know something kind of amazing. If you're standing on the equator, are you moving? If the Earth is rotating, are you moving?
Yeah, you're moving.
I'm gonna say
Of
yes.
course you are. You're going with the Earth, right? Well, what if I asked you to calculate the speed of a point that's on the equator, right? What if I said, let's calculate the speed of a point on the equator? Now, this is from somebody watching the Earth, right? Because you and I are standing on the Earth. We don't know that we're moving. We can't feel that we're moving, right? We'll talk about that later. But anyways, do you remember how to find the speed? What do you put the speed? By the way, we use the letter V. Do you know what the V stands for? It stands for another
Velocity.
word, velocity, right? That's right, velocity. So what's the speed formula? So do you remember the speed on the 101? What's the speed on the 101?
65
65.
65 miles per hour, right? So what's miles? What's miles? Kaylee and I talked about it before.
No.
Is it time? No. It's distance, right? It's distance
per mile.
divided by hour, which is time. That's the formula right there. So if you're on the equator and you go once around, how far do you go? And we just figured it out, right? 24,000 miles. And how long does it take the Earth to make one rotation? How long does that take? And the answer is 24 hours. Can you do the math? 24,000 divided by 24. What do you get? 1,000 miles per hour. Is that crazy?
Wait, that's how.
That's how fast a point on. That's how fast a point on the equator is moving. Isn't that crazy? Now,
Yeah.
we live up here. We live above. We live, you know, in Santa Barbara, which is going to be up here somewhere, right? So we're not going that fast. We're only going about 800 miles an hour, which is still pretty fast, right? But anyway. All right, guys. So that's my office hours. It's a chance for you to come and ask questions, and I guess I used it for a little lecturing too.
Yeah.
But basically, I'm going to send out a questionnaire today and ask you the best times to have this office hour, because it's really meant to be for you.
Yeah.
So you guys, when you get that questionnaire, just let me know. And your only homework to do today is to upload a little video. Actually, let me go back to my face so I could talk to you guys. So your only homework to do today is, actually wait, so there you got a lot more homework. You got to read chapter 1, right? But the only thing that's due is to upload a video clip about yourself. And if you want to do the extra credit, which I would encourage you to do, then you can do that. Yeah, you already did it? Awesome. Oh, I love it. I love it. And I'll go look at all that stuff today, actually. So thank you guys for being here. I really appreciate that. And maybe in the future we'll get more people. We'll figure out a good time to have more people. But basically, that's it. Thank you guys. And all right, so you guys you know what to do. You got a good start. You ready to go? It's going to be fun. We're going to learn a lot, all of us, because I'm learning every day. I promise. And so part of what I'm going to be working on today is that the quiz that I mentioned for chapter 1, and then the test for chapter 1. I won't ask you to do the chapter 1 test for a couple of days, though, at least. Okay. In fact, I want you to wait until the ideas get locked in a little bit. Okay. So we're not in a hurry. We are in a hurry, but we're not, right? I want to give you time, but it is important that you try to keep up with the work. Okay. So chapter 1, if you want to get ahead, chapter 2, by the end of the week, chapter 3, right? That's how fast we're going to go.
Okay.
Okay.
Yeah, sounds good.
Thank you, guys.
Of course.
All right.
Kelly,
Great. I'll see you later.
See you
Have a
later.
good day.
You too. Okay. See you
Bye.
later. Bye. Hasta luego.